Hello everyone, and thank you for returning to All Things Technical YouTube channel. We explore all kinds of technology, vintage technology. We do electronics and mechanical repairs. We play with 3D printing, repair vintage radio and TVs, do some ham radio work, QRP, and just about anything technical. Lots of variety. And if you're a subscriber, thank you for returning. And if you're not a subscriber, how about considering clicking on the subscribe button today so that I can keep you up to date and that you can enjoy the entertainment and education of all things technical. Today, we're going to walk through a 3-month project. And what you see today may be a first ever in the blending of a 57-year-old technology with new and current technology. What we have is a 1964 IBM Selectric 1 Model 711. These typewriters were highly desirable in their day. In fact, they're still being used somewhat. Some of the later models are, where we will create an interface that unobtrusively allows this typewriter to work as originally designed and also work as an external keyboard for an Apple iPad or iPhone. This project offered several challenges along the way, the first of which is that the 711 IBM Selectric 1 has around 2,800 parts, very complex and very compact. So figuring out a way to interface with the mechanics of the typewriter keyboard required a lot of experimentation. And we're going to see some of this experimentation in this video. But the video is condensed from many hours of trial to its completion. And I think that you'll be pleased with the final result. This idea originated with my daughter, who thought it would be clever to give her fiancé an IBM Selectric 1, and he has some emotional attachment to that particular typewriter. I won't go into that today, but she also thought it would be very nice if we could actually interface it with his iPad mini. And of course we thought, yeah, great idea, not sure it can be done. Well, now we know it can be done. I'm not sure that it's something that I would like to do again. Someone made the comment, oh my goodness, you ought to do these and sell them on the internet. I don't think so. It's a lot of work. It would be very expensive to duplicate this work again. And so in any case, this is a one and done project, and I hope that you enjoy seeing how we went through the process of designing the keyboard interface and the software and the renovation of an IBM Selectric 1 Model 711. We started with the IBM Green typewriter that we found on the internet, stripped it down and did some repair on it. I used to work on these years ago, so I was pretty familiar with the IBM Selectric. So I tore it down and did some repair to get it to type correctly. And then my wife, as you can see here, who was a proficient typist, tested it out to make sure everything was working correctly. You may recognize the ball that's spinning there. And the Selectric ball was exchangeable with a number of different fonts. And so that's what made this typewriter so desirable and so complex. So we started with a basic IBM Selectric 711 typewriter and began to work on the interface from the mechanical keyboard to an electronic interface for the iPad mini. So after a little bit of experimentation, we're going to jump right in here and look at the first attempt to interface the keys. This is an IBM Selectric 1, and you may recognize it as a IBM Selectric is the typewriter that types with a ball. And I got this typewriter off eBay, and got a good deal on it. These working models are selling for around $500. I couldn't believe it, but I got it for a tenth of that. But what we decided to do is my daughter wants to interface this typewriter, this IBM Selectric, and be able to plug an iPad on top where the paper would go, and plug it in to the typewriter, and be able to type while it's typing. The balls bouncing across the page. It would also send those keystrokes to an iPad on the word processor. So this is an electronic interface to the mechanical typewriter. What we discovered was that there are basically, for the letters and numbers, there are 6 control rods here. A combination of these 6, so 2 to the 6th power, will give you combinations of like the first 2 bars, or the first and 3rd bar, or the first, 2nd, and 5th bar, whatever, corresponds to a specific letter or number on the keypad, on the keyboard here. So each one of these has a unique, I'm going to call it, digital code of these bars that bounce when you touch the key. So after some experimentation on trying to figure out how to monitor, instead of monitoring every single key for a key press, which would be a big deal. You'd have to put a micro switch on every single one of these, and that would be, there's not a lot of room in here to actually put a switch, because the base of the typewriter comes right up against this. So what we decided to do, and discovered that these 6 bars right here correspond to the motion of these bars that pop out. So these bars bump up, and anytime you hit a keystroke. So what I did was I created this micro switch array, and you can see these micro switches here mounted on bars, and then mounted on retaining clips. There's a retaining clip that I created, and there's another retaining clip back underneath there, and then the switches are all epoxied in place so that they don't move around. And then they're wired for normally open, and the contacts close when you touch the keys. So it creates a switch closure anytime you touch a key. So the combination of these binary, like 0, or this would be 1, 2, 4, 8, 16, 32, or 2, 4, 8, 16, 32, 64. So 64 different combinations of keys, or combinations of these push rods will appear at the end of these wires here. And I'll plug these wires into, we're going to hook these into a little micro computer, a Teensy version 3.2, and we'll show you all of that when we get that far along in the project. So this takes care of this array switches that just bolts right into the typewriter, doesn't interfere with the operation of the keys when you're typing using the ball and regular paper. Works beautifully. So this just monitors those keystrokes, and then we'll monitor those with a computer, and then make it to appear through a USB cable on the iPad. So there are a couple of other pieces to this puzzle here. There's a carriage return switch down here that I had to mount that monitors the carriage return. And then there's the space bar and the backspace, which are separate functions. And they're buried way back up inside here with 2 micro switches. So these 2 micro switches, you can just barely see them, and it took a while to figure out how to rig a bracket to hold those micro switches in there where they're out of the way and are not bothered by anything or hit by anything, but monitor the carriage return and backspace, or excuse me, space bar and backspace. So this is a carriage return here, and then we have space bar and backspace. Now there's a couple of more functions that are monitored. One is called an indexing, which is just another line feed functionality, line feed. And we don't need that because we can use the indexing works just like hitting the return key several times. So we've got backspace, return, and space monitored here, here, and here. And then we've got all of the alphabet and all the numbers. And I've got one more switch to monitor, and that is the shift key. So I'm working on that now to monitor the shift key that of course capitalizes the letters. So I'll figure out a switch combination somewhere here. I can't put anything in here, there's not enough room. Let me show you the switches that I'm using. Get these micro switches on eBay for 20 of them for $6 or something like that. And they're very small, but they will work great for very low voltage application. And I'll mount this in here somewhere. Look for the shift key. I might be able to mount it in here like this, back up inside here, so when you push the shift key, it'll trigger that switch. So we'll figure it out. I could come off of that screw right there and come right up and just put it right in there. So all of these leads will end up, and 4 more wires there will all come together and come in behind the typewriter into a barrier strip. And then we'll mount the electronics, the little microcontroller, and the USB cable will come out and go up to the top of the set. So that's where we are right now, and we'll continue to show you the progress. So you can see the little black and white micro switches there on the setup. They haven't been wired yet. There's 3 more of them right there. And here I'm going to work the action of the push bar that happens when you type a particular letter, and you can see how the micro switches are turning off. And then in this short clip, I want you to see a slow motion of, as I press a key on the typewriter, you can see the micro switches being engaged. The loud clanging sound is the slow motion sound. But you can see different keys strike different combinations of these switches. And so depending upon which key I pressed on the typewriter, it would press different combinations of the micro switches. And what you're seeing here is actually 20 milliseconds. The switch is closed for 20 milliseconds. It's not a lot of time, but it clearly is enough time to work with the computer to be able to watch for a switch closure, a 20 millisecond switch closure in the software. And then here it is in real time. So in order to determine how fast the switch closer was, I hooked up a small battery and the scope to watch how quickly the switch opens and closes. So you're seeing noise there on the bottom of the scope, and then as I type a key, you'll see it, a square wave jump to the screen. And after a little bit of adjustment with the scope, I was able to monitor 20 millisecond spikes, if you want to call them that, a 20 millisecond square wave on the screen. and that's how we determined the speed. There's one right there and another one, and they're roughly 20 milliseconds. You can see them appear on the screen there, and it's basically one graticule, one square on the scope, which is 20 milliseconds. I will add that we were concerned initially that the switches would be able to turn on and off quickly enough and give us a clean spike to be able to monitor with the microcontroller, and so this proved that we would be able to do that. Switch, spacebar switch wired in, and the backspace and backspace and space, and then down here is the return. So it's all ready to wire into the barrier strip. Typewriter all wired in here, and all 12 switches wired into a breakout box for Jesse, a barrier strip actually it's called, and he can wire the computer into this, and we'll mount the gooseneck back here below the IBM Selectric label. So I just got this all cleaned up and degreased and ready to paint. So I'm going to go ahead and snap this back on here and then button it all up and take it over to Jesse's shop, and he can begin working on the electronics. Okay, excuse the chainsaw work in the background there. Okay, here's what we have so far. The interface is wired into all the switches. Doesn't look too terribly complicated there, but Jesse wrote the code for this keyboard cable. Comes up to the iPad mini, and of course you can see the bracket that holds the iPad mini in place, and it's adjustable, of course, for use. So let's turn it on here. I think I've got well, try that again. There we go. Yeah, see, I got a notepad open here, so let me turn the typewriter on. I'm sorry, I'm covering the camera. So the typewriter's running. I don't know if you can hear it. All of the keys and a control key. This is a control key. We've got it wired for control. So you got control functions like page end, home, backspace, delete, all that kind of junk. And it all interfaces to the keyboard here. So I've got the tape turned on to stencil so it doesn't use up the ribbon, and the ribbon's kind of tangled up in there, but that's okay, we'll fix that. But anyway, it's on stencil right now so it doesn't use the ribbon while it's typing in iPad when the iPad is hooked up. But let me just go ahead and type here. And obviously I'm not a typist. So there you have it. These keys on the control key, some of these keys work as arrow keys, and we'll put little labels down here on the bottom of the keys to identify what their secondary or function or control function will be. And so here is the IBM red cat repainted, the green typewriter to Andy's favorite red IBM, and it turned out beautifully. it's a Selectric 1, and we've added an iPad, and you can see the interface, the mount on the back. We'll take a little closer look at that. But the uses a regular lightning cable here and an interface, and we've wired, as you saw, the wiring of the set to run. It's on. It's running right now. So let's put a piece of paper in the typewriter. Okay. And when you turn the device on, it automatically powers the external keyboard interface. So I'm going to type on the keys down here, and we're going to watch it. Let me see if I can back up and get it all on the same screen. We'll watch it on this screen and on the typewriter here. You can see that it's typing. Jesse has it programmed for doing page up and page down and line forward and all of that kind of stuff. Control A would be selecting all, and then Control X is delete, or Control Z is undo. Control A, copy, and then I don't know what down is. We'll find it here in a minute. Now that's page end. Okay. Anyway, let's go to, there we go. Let's do Control V for paste. So the control functions work like they would on a normal keyboard for the external keyboard for the iPad, but then we also have the typewriter working like it normally would. You can see that all the junk that I typed there, all those funny looking keys. So anyway, we have it put on stencil, and it will not advance the ribbon and allow you to just type on the iPad. So I don't know if anyone else has ever done this, but it's definitely working like a champ. And across from the IBM Selectric Model 71 to a modern day device like an iPad or any touchpad device, Android or whatever. This software is designed to work with an iPad because of iPad's, an iPhone and Apple's particular use of the control key versus, or the command key versus the command key versus the control key. Well, there you have it. We made it through this project. It's been a long 3 months working on the interface, but it's been a great project, and one that my son and daughter and I worked on together, which made it extra special. So I think my daughter's fiance was very surprised and pleased with the end product, and I'm just tickled to be able to share our project with you today.